Hello friends, today we are going to discuss about the Michelson Interferometer. So in this Michelson Interferometer, this it consists of the two mirrors M1 and M2, which is highly polished, and two glass plates A and C, which are parallel to each other. The red side of this glass plate A is half silvered, so that light coming from this source S is equally reflected and transmitted by it. Light from the monochromatic source S, after passing through this lens, monochromatic lens, this lens falls on the plate A. The lens L makes the beam parallel. The plate A is inclined at the angle of 45 degree. So the one half of the energy of this incident beam is reflected by the plate A towards the mirror M1, and other half is transmitted towards the mirror M2. These two beams, means reflected and transmitted, travel among the two equally mutually perpendicular paths, are reflected back by the mirrors M1 and M2. These two beams return to the plate A. The beam reflected by mirror M1 is transmitted through this glass plate A. The beam reflected back by the mirror M2 is reflected by the glass plate A towards the eye, and the beam going towards the mirror M1 and reflected back has to pass twice through this glass plate A. The beam to compensate for the path, the plate C is used between mirror M2 and glass plate A. The light beam going towards the mirror M2 and reflected back towards A also passes twice through this compensating plate C. The path of the two rays in the glass are the same. So the mirrors M1 is fixed on the carriage, and and moved on the help of this handle H. The distance through which the mirror M1 is moved, read on the scale. The planes of the mirrors M1 and M2 of the fine screw attached to them. The compensating plate is necessary for the white light fringes, but can be dispersed with while using monochromatic light. If mirror M1 and M2 are perfectly perpendicular, the observer's eye will see the images of the mirror M1 and M2 through A. There will be an air film between the two images, and the distance can be varied with the help of this handle H. The fringes will be perfectly circular, and if the path traveled by the two rays is exactly the same, the field of view will be perfectly dark. Uh, if the two images of M1 and M2 are inclined, means M1 and M2 not perpendicular, the enclosed air film will be wedge shaped and straight line fringes will be formed. So when mirror M1 is moved away or towards the glass plate A with the help of this handle H, the fringes cross the center of the field of view and of the observer's eye. If M1 is moved through a distance lambda by 2, one fringe will cross the field of view and will move to the position previously occupied by the next fringe. So there are the three types of fringes: circular fringes, localized fringes, and V-shaped fringes. The circular fringes are produced with the monochromatic light in Michelson interferometer. Here the mirror M1 and M2 dash, which is the virtual image of this M2, must be parallel. Means when M1 and M2 dash coincide, the path difference is 0 and the field of view is perfectly dark. When M2 dash is nearer the eye than M1, the fringes are like this, and when M2 dash is further from frame of eye than M1, the fringes will be like this. So for the white light fringes, the pattern of this fringes will be means when M1 mirror M1 and virtual mirror M2 dash are inclined, the air film enclosed the V-shaped and straight line fringes are observed. With the help of white light, the fringes are observed only when path difference is small. So this is about the Michelson interferometer. Means in Michelson interferometer, this is the construction of this Michelson interferometer. Means the two mirrors M1 and M2. This is the monochromatic source. This is the lens which makes the beam parallel. This is the partially silvered, and this is compensating plate. This is the handle, this is the scale, and this is the view through which we can see the fringes. So when the M1 and M2 are coincide, the fringes will be the pattern will be dark, and when the M2 dash is near the eye than M1, these circular fringes are observed. When M1 and M2 dash, which is the virtual image of the M2, mirror M2, coincide, we can say see the straight line fringes. And this is about the Michelson interferometer, the construction, and the three types of fringes, that is circular fringes, localized fringes, and white light fringes are observed in the Michelson interferometer. So this is all about the Michelson interferometer. The construction is already told about this Michelson interferometer. Means two mirror, which is a mirror M1 and M2, one is fixed and other is movable with the help of this screw. Monochromatic source S, the lens L. This is about the handle H through which we can move through this mirror. This is the scale on which we can read the reading regarding this movement. This is the compensating plate which is placed between plate A and mirror M2. The plates are inclined at the angle 45 degree, and the rays which is partially reflected towards the M1 and partly to the M2, then coincides with the here, and we can see the fringes. So this is about the Michelson interferometer. Thank you.